So let's start with a tangent and secant intersecting a circle. So if you have a circle and the circle has a tangent segment and a secant segment passing through, the relationship that exists, let's call the tangent segment A, the external portion of our secant B, and the internal portion of our secant C. The relationship that exists in this type of intersection is the tangent segment squared is going to equal the product of the external secant segment times the entire secant segment, which is B plus C. So this is the equation relationship that's going to exist in this type of intersection. So let's take a look at an actual example of this. So if we took a circle intersected by a tangent and a secant, and let's say the tangent segment has a length of 4, the secant segment has a external length of x and internal length of 6. So when you take this relationship, you can apply the equation that the tangent segment squared is equal to the external portion of the secant times the entire secant, which is represented by x plus 6. And so now you just do the math for this. Square 4, distribute your x, you get x squared plus 6x. Move everything to one side, so you're solving this quadratic equation. So we subtract a 16 from both sides. What we can now do is look to factor and apply the zero product rule. So when you're finding binomial factors of this trinomial, your first terms will be x, your second terms have to have a product of negative 16 and a sum of positive 6. So positive 8 and a negative 2 would work for that. And when you set each of these factors equal to 0, you get two possible solutions, negative 8 and a positive 2. Well, since your x value is a distance, it can't be a negative number, so our answer winds up being 2. And we can verify that if we plug it in. 2 times the whole length 8, test to see, is that equal to the tangent squared? And when you compare these, 16 does in fact equal 16, so it checks your solution.